in 13.99 is the same, except they're saying they want us to determine the actual Van Hoff factors. They're saying they actually put this together, they made the solution 0.4 molality, and they measured the change in the freezing point. They measured it to be negative 2.6. So we expected negative 3, but what we got was negative 2.6. So if we put that in, make it equal to Kf, and we got the molality, and we want to solve for I now. We want to know, we expected the Van Hoff factor to be 4, but what is it really? So then I just need to divide both sides. So I've got negative 2.6 divided by 1.86 divided by 0.4, and the Van Hoff factor I get is 3.5. I knew it was going to be less than 4, I just didn't know how much less. Right? And the reason it's less than 4 is because I don't actually get 3 plus 1, 4 total ions. Some of the ions pair up. In actuality, I get 3.5 separated ions on average for every one of these intact units that I dissolve in water. Then I might say, in a follow-up question on the exam, I like to do that. These follow-up questions, I might say something like, if the molality was 0.8 instead of 0.4, would I increase or decrease, and why? And then I might have another follow-up question where I say, if that were true, would the temperature of the freezing point increase or decrease, and why? If I were at a molarity of 0.8 instead of 0.4. So what's the answer to the first part there? If I increase the molality, the value for I decreases. So it's going to decrease because at a higher concentration, the ions are closer together and they pair up more. And so I have fewer total independent particles, and so I have less of an impact on the freezing point, and that's what I is a measure of, the total number of particles. The freezing point would actually decrease. And that's because if molality increases, then the freezing depression increases because they're directly related in the formula. So having 0.8 molality instead of 0.4 means I've got double the amount of particles. So with more particles, it's going to affect the organization of the water twice as much, and it's going to take twice the change in temperature. So instead of a freezing point of negative 2.6, I'd add something closer to negative 5.